Hello and welcome to today's session of programming. As you can see, today is a bit different. I want to try to make a scripted video instead of live coding and try to condense the information a bit into a short video instead of an hour-long watch. I recently got back into Stoicism and have been journaling again. Nothing heroic, just trying to notice how I react. Today I'm showing you an AI diary I built. Local first, private, vector-backed and pragmatic. I want you to leave with something you can run and understand. We are using Java 25, Quarkus, Vaadin, PostgreSQL plus pgvector, Ollama, Llama 3.2 and LangChain4J. No fluff or anything, we'll do the infrastructure, vector magic and a short demo. Okay, so let's jump right into our little repository there. So I have created that little diagram which shows what's going on. We are using Docker-compose to start up 4 containers. Basically, we have the front end where we'll have our user interface, which is running in Spring and uses Vaadin. We have our back end with Quarkus and LangChain4J, and that is using Postgre with pgvector extension. And we have Ollama, which is now not running Llama 3.2 anymore, but Qwen 3. I actually changed that, but forgot it in the diagram here. Now let's go to the Docker-compose file. I have this Johannes Raubauer AI journal repository, and I created the Docker-compose as usual. I love that Docker-compose file and that you are able to get into that file, into that repository, simply call docker-compose up and everything just runs. It might take a while because it is booting up Ollama, and it does so with GPU support, which is great for us because it helps speed up the whole request stuff. I have the latest version of it. I want to store the models outside of that container, so every downloaded model is outside the container. If I delete it and restart it, it's still there. I have a little init file. We can actually go into that right away, and what it does is it pulls down the Qwen 3 embedding model and the Qwen 3 chat model, which we both need. We'll see why and how it's used. And then I wanted to keep the models alive as long as possible, because otherwise models get unloaded after a while, and I don't want that in this case. If I start up the Ollama container, the models should stay loaded. And because we are using 2 different models, they should be in the memory at the same time if possible. That's it about the Ollama file. Then we go on to the database, which we'll need. It's a PostgreSQL database with the usual stuff like username, password, stuff like that. We map it on a different port outside. We have a little health check because we actually want the backend to wait for the database. Otherwise, the backend will shut down because it sees that the database is not available. So we need to implement a little health check and wait for it to be actually up. As you can see in the backend, we depend on the DB and with the condition service healthy. So this helps with defining that. We have the volumes, so the data is also mounted outside the container because that's nothing you want to have dependent on the runtime of the container. And we have a little initializing script to actually install pgvector. And here we have the Docker file for our pgvector installation. We are using Postgres 17, which isn't the latest, but it's late enough and it's working flawlessly with this little script. And it's actually just installing the pgvector stuff onto Postgre. And then we are enabling that extension with this little command. Nothing spectacular here. All right, so we got Ollama, DB. We have the backend container, which is a Quarkus system that is dependent on Ollama and the DB. We have a couple of environment variables, but not a lot. We want to say that Ollama is used, and we have to specify the URL, and we have to specify which DB is used. Normal stuff. Let's take a look at the Docker file here. That's nothing to write home about as well. We are using Temurin 25 here. We are firstly copying the Maven project file and downloading all the dependencies, because I hate it when it takes such a long time to build. And if you have to download all these dependencies every time you do a small change. So by splitting the downloading of the dependency and the actual building of the Maven package into 2 steps, we actually make sure that even if something is changed in the source code, it's still using the already installed dependencies if they did not change, which is quite cool. And then it basically just builds that project, and it makes a new stage of in the container, which uses only the runtime of Java, copies the created jar files, and then runs that stuff with Quarkus run. So pretty simple, but it has the great effect that nobody needs to install any specific version of Java to get that stuff running. I love that. Okay, and then last but not least is the front end, which is basically the same thing. It simply depends on the backend here. It has the URL to the backend and is running on the port 8081, and we can look at that. That's actually not a Quarkus, but a Spring container, just to mix it up a little. And I made the experience that Vaadin works especially well with Spring, so we are using that here. Yes, and we basically have the same structure. We download the dependencies, then build the actual project, take a new stage, and then copy the jar into that and start the jar. To show you what I am actually doing is, this is the application. It's very simple UI. We can type in our journal entry. So what I wrote is today was a good day. I had loads of fun at the museum, but on the way home I got into an accident and I got hurt pretty bad. I got angry at the other driver because he bumped into me. That sentence is supposed to tell me something about what I could do better. Let's try that out. I hit save. It saves it as an entry, and then it starts to think about the AI remarks. We will see what happens in the background later on, but right now we are just waiting for that answer. Okay, so the results are going in. This is great. It specifies or extracts the mood which was given. It actually references some quote from Epictetus and an actionable advice, which is pretty good. So we should reflect on the accident and the pain from today. And then later on, focus on cultivating compassion towards yourself and others. So I get pretty angry at the other driver means, well, I should have more compassion for him, maybe. Okay, so this is the basic thing, and it's also stored. So if I hit refresh, it should, yeah, I tried that 2 times. So this is great because we can actually journal a new entry tomorrow, and it will log that as an entry and log the AI remarks to it. And what it does is it also vectorizes these entries, not just our entries, but also the AI remarks, and it will retrieve them in the memory. We will see that later on. What I mean is when I say that text is embedded, is that it actually turns these texts into numbers, into vectors, and puts them in the database, the PostgreSQL database. And it actually turns these texts into numbers, which then can be retrieved later on. So if I say, I am nervous about tomorrow, for example, then this is stored into vectors. And if on another day I say, well, I am scared about tomorrow, then this has very similar values, very similar numbers to the text, I am scared. And what I can do then is in the database, I can search for similar vectors. So if I say I am scared about tomorrow, I can very easily find the text I am nervous about tomorrow because it is very similar in these vectors. And by that, I can actually retrieve relevant texts from the database into my LLM context. And how do we do that? We'll see that right away. Here we are in our backend, and we are in the main resource. And we actually just have a couple of endpoints. The first one is new entry, and that happens if a new entry is entered by the front end is delivered to us here as a new entry. Let's go to that one. It's just holding the entry text that was input by the user and the timestamp. And we are responding with a multi-element, with a small mutiny multi-element, which actually gives the return value asynchronously, which is kind of great for that purpose because we can just listen for new strings and write those down in the front end. Okay, we have our little diary AI assistant. We'll get to that, what it does, but it actually does analyze our diary and simply returns that as the response. But we also want to do something with it. If this is done, if the response is done, we actually want to embed that result and the entry as a new entity. And this is actually where a lot of the magic happens, but we'll get to that in a second. Let's finish our endpoints first. And here we have our entry. So this simply returns all the processed entries which we have in our little journey. That is basically, if we get to the, just call for the repository to get all the entries out and back to the user. So this usually happens if the user gets on our site for the first time to load all the existing entries. But this is not the heart. The heart is this one. And first of all, let's get into the diary AI assistant, which should be pretty simple. So we have our system message for the AI chat client. By the way, where do we define what our chat client is? we have it here. That is a Quarkus property, and we tell him to use Qwen3 1.7. All right, back to the diary assistant. So this is our prompt. It should extract the mood, the key scenario, growth insight, and actionable advice for the next day or for the next time, right? Which, yeah, also pretty simple, but we have a little bit of a twist here. We have our diary AI assistant provider, which simply creates that assistant. And what that does is it actually creates a content retriever. So we are not just getting stuff out of the LLM, we actually have an embedding store, the pgvector embedding store, which is also just a class from Quarkus. Pretty cool. We don't have to do anything else here, just a couple of configurations like this one and pgvector, the dimensions, and, well, of course, the data source. But that's all we have to do. This is pretty crazy in my eyes. Yeah, and then we give that the model and the embedding store to our little LLM, combined with our memory provider, because we have to, we want to create a little bit of memory. Let's go to that JPA chat memory, and that retrieves the last 50 messages, which may be a bit too much, but yeah, that's what it does. But additionally to those 50 messages, we have our pgvector, and that gets our closest entries into that memory window as well. And that's pretty cool. So that means if we have, for example, again, about a year ago, I was scared of the next day for whatever reason. If today I am scared of the next day again, it will get the data out of the database and into our memory provider. And that is pretty cool. So it remembers stuff long, long ago just because it had similar context. And that's what we are doing here. Okay, so this is the retrieval, but of course we actually also need to ingest that knowledge here, and that's what we do with the embed and store new entry method. Yeah, again, we have our pgvector embedding store, we have our embedding model, which is the what was it, Qwen3 as well, Qwen3 embedding. And we give that into the ingester. So again, another Quarkus, no, LangChain4J class, sorry. And that's actually making these embeddings and then ingest it into our pgvector embedding store. And that's pretty easy. So we create a document from the actual entry text, but additionally, we give a metadata, which is the timestamp on which date or which time this was inserted, and also the AI hint. So what did the AI say about that? And that's about it. It's really quite minimalistic. We ingested here all that knowledge. By the way, yeah, we have the repository as well. So this actually just persists the new entry in the normal database. Yeah, but that's it. And that's pretty crazy, right? So here's another example. If we get in a new entry saying, I'm nervous about tomorrow's presentation, then this will get converted to a vector or embedded into a vector. And with PostgreSQL and pgvector, we can actually do a query like that, but we don't have to do that manually, which is great. We just set that in our Quarkus and LangChain4J objects. And then we get back the 5 most similar parse entries for that. And they can be a long way in the past, but if they are in the database, they are found pretty fast. And then the LLM sees those entries in the memory context. And that is pretty wild and really useful, because then it can actually reference events that happened a long time ago. To summarize that, how the workflow goes, we have the user who submits an entry into our journal. The front end calls the backend with a post on new entry. Then the diary is analyzed with Ollama stream. The actual stream token is given back to the front end, and this analyzed diary is using PostgreSQL to retrieve the vectors and at the same time then store and embed the new vectors and the new entry. Pretty simple, but pretty powerful. We actually split the complete diary entry into sets of 500 tokens. So if you insert 2000 tokens, this will get split into 4 chunks, because at some point you have to chunk those texts to make it better to find those. And as a final thing to do here, I want to start the whole project with this simple command without needing to do anything else. You really just hit docker-compose up and build the whole stuff. You don't even have to use the build command, because it must be built anyways. So as you can see here, Ollama is doing most of the stuff, doing most of the work, but it's actually just booting up everything, the front end, the back end, DB and Ollama, and then it just runs. So I really hope you enjoyed that video. And please tell me if you like that format better than the other one. I know this is much shorter and condensed, and I think most people like that more, but we are missing the interaction with any live chatters, which is a bit sad. And this requires, of course, more work, because I need to do some preparation and some cutting. Yeah, but if you enjoy that content, please leave a like and subscribe, and most of all, a comment would be really appreciated. I hope you learned something. I certainly did, and I really enjoyed that project. I still like to program AI projects. Have a great day. See you next time. Goodbye.